Okay, we're going to get started. I'm Judy Greenwald. I'm the Executive Director of the Nuclear Innovation Alliance. Welcome, everyone, and thanks for joining us today. We here at NIA are pleased to host this webinar on our latest publication, Promoting Efficient NRC Advanced Reactor Licensing Reviews to Enable Rapid Decarbonization. NIA is a nonprofit, nonpartisan think and do tank working to create the conditions for success for advanced nuclear energy as a climate solution. Through research, analysis, and education, we inform decarbonization and innovation policy. We've played a leading role in forming major federal legislation to reform advanced reactor licensing at the Nuclear Regulatory Commission and to expand the Department of Energy's nuclear innovation efforts. We also collaborate with stakeholders to coordinate advanced reactor advocacy in the United States. The NIA team created this report to investigate how to make advanced reactor licensing both more effective and more efficient. Unnecessarily long licensing reviews can raise significant barriers to investment, reduce customer interest in advanced reactors, and threaten their successful long-term deployment. As of now, the current NRC licensing regime takes too long for advanced reactors because it is oriented toward conventional technology. We found that there are actions that both the NRC and industry can take to reduce licensing durations while ensuring safety. The key is to bring a sense of urgency, focus on maintaining safety standards, and improve both industry applications and NRC regulatory processes. Historically, NRC often takes 5 years or more to conduct a license review and make a safety determination for a large light water reactor application. This length of time reflects both the engineering complexity of such reactors as well as the length of their project life cycles. However, simpler, smaller, and even safer advanced reactors would benefit from more effective and efficient licensing. Due to a host of emerging factors, especially growing concern about climate change and shifting energy market demands, the public needs advanced reactors as soon as possible. In light of recent bipartisan support in Congress for advanced nuclear innovation, NRC and industry can drive rapid deployment by reimagining advanced reactor licensing to enable business models that reduce costs and meet the public's need for clean energy. I'm honored to introduce former NRC Chairman Steve Burns, who will moderate a discussion about our new report. Steve served as a commissioner on the Nuclear Regulatory Commission from 2014 to 2019 and was the chair from 2015 to 2017. Formerly, he was head of legal affairs at the OECD Nuclear Energy Agency in Paris and had served for over 30 years in various legal positions at the NRC. He's currently a senior visiting fellow at Third Way. Steve, thanks so much for moderating our conversation today. I'll now turn things over to you.
Well, thanks, Judy, for that introduction. And I want to welcome everyone to our webinar this afternoon. It's an interesting topic because as I recall, as I came onto the commission in the about late 2014, one of the issues in front of us was this question about how does the agency move forward in terms of advanced reactors, which we're starting again to have much more interest shown in them. And currently, one of the things we have is both instruction through legislation for the adaptation of a more technology neutral, risk-informed framework, which the NRC has labeled Part 53 that they're working on. But at the same time, we have some applicants and interested developers who will try to pursue their new designs through the process. So we've got a couple things going on at once. And I'm happy to have this discussion today on the Nuclear Innovation Alliance's report. And we're going to hear first from two of our panelists. First, Alex Gilbert, who's a project manager at NIA, where he is responsible for managing and conducting project research, stakeholder engagement, and related activities. He leads the research and advocacy related to technology commercialization, regulatory modernization at the NRC, and federal policy. He is also a non-resident fellow at the Payne Institute for Public Policy at the Colorado School of Mines, and he's an adjunct on the adjunct faculty at Johns Hopkins University, where he co-teaches a course on nuclear policy and regulation. And second, I want to introduce Amy Roma, who's the global energy practice leader at the law firm Hogan Lovells. And in her practice, Amy advises clients on a wide range of legal, business, and policy matters involving the commercial nuclear energy industry, including issues related to the existing fleet, advanced reactors, fusion facilities, and supporting nuclear infrastructure. So I look forward to hearing from both of them. And Alex, I think you're going to kick it off.
Thanks so much for that introduction. So I'm going to run briefly through the high-level results from our report, as well as what we think is the importance of the report itself. So to start off, when we're kind of looking at this issue, we're looking at this from a public policy perspective of we need advanced reactors for climate mitigation. We need them to be here as soon as possible because we want to reduce emissions as much as possible. And licensing is part of the project lifecycle. So the length of licensing directly impacts how long it takes a project to be developed and get to market and start producing power. And when we look at advanced reactors specifically, one of the main ways that we're going to try and reduce costs and make these an economic clean energy source is by making them a generational model. We're able to learn lessons. We're able to incorporate new techniques for construction, new ways to get efficiencies, new business models. And so the shorter your project lifespan overall, the more likely you are to be able to develop an economic model. And so this is just a very basic graphic to illustrate the principle. It's a lot more complex than this. But when you have a shorter time frame between generations, you accelerate the deployment of the reactors and the economics of the reactors much quicker. So the shorter that you can get the overall project lifetime, including the licensing lifecycle, the quicker we will see advanced reactors get to market. So with that in mind, I just want to kind of start at like a very basic question. How long should licensing take? This is just a really easy way to kind of frame this issue. When we look at NRC and what it does, licensing should take as long as needed to reach a finding of adequate protection of public health and safety. We need to have the regulator have enough time to be able to reach that finding or to not reach that finding. And so a licensing process that might take 5 years for a certain type of reactor could take a lot shorter for other types of reactors. And so that's where we're kind of starting this analysis, is that we're not trying to change any of the substantive parts of regulation. We're not trying to make things less stringent. All we're trying to do is focus on the process to meet the same standards that we have at the NRC. So when we look historically and when we look at large light water technology, what we've seen is the review times for projects over the last 20 years or so have been relatively long. And these timeframes are just not consistent with what we need for advanced reactors to be able to get them to market quickly. If you look at both the environmental and the safety review for all sorts of different facilities, you'll see sometimes things are approaching 7 or more years. And that is a significant challenge if you're trying to do a lot of these projects quickly. Now, there's a lot of reasons for this, and we'll get into this, but one of the highest level things that we need to always keep in mind when we're talking about changing the regulatory system at NRC, when we're doing regulatory modernization, is that everything that we have structure-wise in terms of the bureaucracy, in terms of the regulations, is based on the fact that it was designed around large light water reactor technology, conventional nuclear energy. These were very large facilities. They are almost entirely were light water reactors. The way that we're using them was very fixed and very similar. And so when you're dealing with a very large, complex machine like that, it might make sense to take a long time to be able to review all of the complexities of the machine. And also from a business perspective, in terms of what the industry needed to get to market, these projects inherently have longer life cycles. Advanced reactors are different. There's a very wide range of them. We have projects that are as small as 1 or 2 megawatts. That's a project that construction timeline is as small as maybe 12 to 18 months, not 12 years in some cases for large light water reactors. So you have a very different project life cycle, in addition to having technologies that might not have the same level of complexity. They might be having different safety features. They might be being used differently. And so when we're switching our regulatory modernization to this new technology, we need to make sure that we're trying to maintain the high level safety standards of the NRC, but we can change the processes to be able to accommodate this new type of technology. And so this was partially recognized by Congress in the Nuclear Energy Innovation Modernization Act in 2018 and 2019. And what they required in that was that NRC develop current generic durations for licensing reviews for a reactor. So when you apply to NRC, you have the safety review. And currently the way the generic durations work is this is the schedule that the NRC staff has created to try and target for an application. Now, an individual application can have different numbers than what we see here, but in most cases, what we see is a construction permit, or operating license, or a combined license, which are kind of the three major pathways under Part 50 and Part 52, take around 3 years, 36 months. And that's something that might not be quick enough for us to be able to have the industry decarbonize at scale. So are there ways for us to be able to get the processes down and get things to be more efficient so that we can reach that finding of adequate protection of public health and safety sooner? So that's really where we're kind of looking at this question. And from our approach, looking at this, there are things that we think that Congress can do. The biggest thing that Congress and the public can do is just instill a sense of urgency that we need these things to be to market as soon as we can because of climate mitigation. But really, our focus is on what NRC and the applicants can do. We think that both of them have a part to play in getting these timelines right. So we have 4 major recommendations. I'm not going to go too deep into all of them because there is a lot of detail, and this is in the report. The first one, which we think is really important, is just pre-application engagement. And this is something that we've seen become increasingly important over the last 5 to 10 years or so. That pre-application, because these are novel technologies, it helps applicants reduce regulatory risk, and it helps the NRC figure out resources, figure out the questions that might be major things they need to figure out from a regulatory perspective. And so we think that the NRC and applicants can work together here and really make pre-application valuable. And I think that's one of the big things we've seen missing the last several years is that applicants don't necessarily always see the value of pre-application. And so trying to figure out how to develop best practices from early cases is a really powerful way that we can work on getting pre-application to be effective for the regulator and for industry. Second is just restructuring how we do the safety evaluation process itself. We think just as an internal goal, NRC could target having a 24-month or less review schedule for many of these types of licenses. One thing that we also think is important is that we're currently developing Part 53 right now. And so as we're looking at how these things can be structured in a way to be more efficient for the current licensing, we hope that those lessons will be able to be adapted for the next regulatory framework we're developing Part 53 to make that even more efficient. And on the industry side, there is this idea of high quality applications that there's kind of some questions about what that precisely means. And I think that industry needs to work that out over time. But really that the applications need to be able to have enough information so that you can start moving quickly on the NRC side. And I think that especially when we get beyond where we are right now, which is the developers mainly have these designs, to actually having utilities building these designs and utilities needing to go through the licensing process, making sure we have formalized ways to exchange information will be helpful here. So one thing that we kind of did is looking at specifically that set of recommendations. We looked at how you could potentially, for a combined license application, change the phased review structure. And we think that using this, getting down to one ACRS review, improving the efficiency of your RAI process, and potentially having 2 rounds or even no rounds of RAIs, which is a pretty ambitious concept, could reduce it so you can get an 18 to 24-month review cycle instead of a 3-year or longer review cycle. Then more broadly, and kind of thinking about how this actually works on a more soft perspective or just in terms of institutional perspective, we think one of the important things here, because we're dealing with such novel technology, is that we need to really make sure that the management and commission can get involved on key questions of policy as soon as possible. So when you're looking at an individual advanced reactor design, sometimes there's only one or two major questions in terms of, here is something we're not sure about how it will be resolved by the regulator, how the industry wants to do it. And getting the resolution on that early on can actually make it so that the overall duration of the review is a lot quicker. And so being able to identify those potential risks, especially if you can combine that with pre-application, can get to much earlier resolution. And then some certain instances, having the commission really actively engage with these review processes just to make sure that they're proceeding at a quick pace can be really helpful. Finally, one thing that we think is just important across the board is building effective communication between the regulator and the industry, and then also to the degree that they're involved with the public. The request for additional information is a huge part of the overall kind of processes on the day-to-day basis. And this is where I kind of think about this as, but as a younger person who has grown up with the internet, this is a system that feels like it kind of predates the internet. That when you look at how the process works, you'll have potential request for information. It has to go through a big internal process at NRC. They then send it to the company, which then has their own process to deal with all the questions about that and send it back. And you can have a request for additional information take several months, even if it's only a small technical question that could be resolved in an afternoon of a discussion. And so figuring out how to change those processes is a huge potential opportunity, but more broadly, just making sure that we can have effective communication between industry and the NRC. So to wrap up, I actually want to use a really good anecdote. So Kairos just submitted a construction permit for their prototype reactor. They did a very effective job in their pre-application, and the construction permit is targeting a 2-year review time frame. So that's the type of thing that we're actually talking about here. And Kairos has done a lot of good things in terms of best practices. So a lot of things that we're talking about are happening in certain reviews or in certain areas, or things that are outside of advanced reactors. And we talk about some of those examples in the study itself. But these are things that if we can take the best practices and spread them across the NRC, we think there can be a lot of opportunity to reduce these durations in a way that is good for the public and is good for climate change ultimately. Thank you very much.
Thanks, Alex. And now I'll turn it over to Amy.
Thanks. Hi, everyone. Amy Roma. I'm a partner at Hogan Lovells and the global head of our energy practice group. I just want to say off the bat, I have a much more informal presentation than Alex's. Alex, I greatly enjoyed that you digested the material in the report into those great slides, and I hope that those will be shared with people afterwards because I think they're very useful. By way of background, for those who don't know me, I'm a nuclear regulatory lawyer. I have been practicing for just shy of 20 years. I began my career at the NRC and have worked on so many different types of licensing of facilities over that time. And while I was at the NRC, I was at the NRC Atomic Safety and Licensing Board, where I spent, I'm just thinking over the years that I've been working, I spent whole years of my career focused on a lot of just key projects. So when I was at the licensing board, I spent over a year of my time there working on licensing challenges to the private fuel storage facility. So I can see it on the back end, where are challenges to applications and weaknesses and what needs to be supplemented and how do things get fixed in the licensing process on that end. And then I left and immediately went into the licensing of the LES enrichment facility. In that proceeding, as explained in the NIA report, there was a commission order early on in the proceeding setting the duration of 36 months for the licensing review and mandating that any key licensing issues or policy issues be sent up to the commission for review and decision on how they should be interpreted during the course of the licensing proceeding. And that worked really well. And that was my first kind of entry into licensing when I was not at the NRC. And I was like, well, this is great. I kind of thought these commission orders were issued all the time. And then we just shift gears over to licensing for COLs, combined operating license applications for a whole host of different applications. And I was really surprised to see that the best practices that I had seen kind of in earlier licensing proceedings, particularly LES proceeding, were not being applied in the COL proceedings, where key licensing issues were stagnating over a course of multiple years, where the commission wasn't having issues flagged for them and providing the guidance like they did in the LES licensing proceeding, and where some of these licensing proceedings were dragged out over the course of 9 years, not tied in with any technical reviews, but looked like a disconnect between applicants and license in the NRC about the application and its review. And so then fast forward now, I'm working on advanced reactor license applications. And I also have worked on a medical isotope license application. And so that 18 to 24 month review cycle that Alex just mentioned non-power reactors. So the Kairos facility is probably a test reactor application, I believe. And so they get the benefit of the shorter licensing review. There's a statutory incentive, I think, to support R&D in the Atomic Energy Act, which permits a lighter regulatory lift for research and test reactors to support the development and promotion of innovation without kind of getting in the way of process. But at the same time, the NRC has applied that 18 to 24 month review cycle for commercial non-power reactors. With the medical isotope facilities, there was a company that was planning on building 2 10-megawatt reactor facilities. They would be commercial facilities that were selling medical isotopes, but it was a non-power facility, so it wasn't going to be providing electrons to the grid. And the NRC indicated that an 18 to 24 month review schedule per application for commercial non-power reactor applications, they have to do 2. So they can't do a COL. They need to do a construction permit and then a separate operating license application. But the NRC indicated that 18 to 24 months per application would be acceptable. But then when you go over to the advanced reactor space, facilities that are similar size or much smaller, such as like the Oklo facility, are not afforded those schedules, and that's a COL. So it's a little bit of a disconnect, but there's not this presumption that there would be if you were in the research and test reactor space or the commercial non-power reactor space, even for very small facilities, about your licensing duration. So it was in this light that I came to this report and worked with Alex and the other folks at NIA, just sharing the experiences that I have had and the disconnect on the various licensing proceedings that I've worked on, things that worked well, things that didn't work well, things that applicants could have done better, things that the NRC staff could have done better, and trying to come up with, where are recommendations that we could focus on to help improve the overall process, make the licensing process more efficient, but without in any way, diminishing the NRC's safety or environmental reviews that it needs to undertake. And so where we saw that there was some room for improvement, certainly in the pre-application stage, as well as during the application review. And in the pre-application stage, some of the best practices that we could identify and that were mentioned in the report were really focusing on key licensing issues early on and tried to come up with a resolution and to an agreement about how that they would be resolved and move forward. Applicants have different approaches to pre-application. Some engage in very robust pre-application. Kairos is an example of that did a very long pre-application. NuScale is as well. I would just note that pre-application is charged to applicants on a time and materials basis. It can be very expensive. And so not everybody has the ability or the timeline to, with their investors, to engage in very long pre-application engagement schedules. And at the same time, because it's being a cost that gets passed on to the applicants, it's really important to make sure that that time in pre-application is spent focusing on the key issues that impact the NRC's review of the application, and that introduce the technology to the NRC so that it can become more familiar with what it's looking at, and the planned licensing approaches that the applicant plans to take to make sure that if there's a disconnect between what the applicant and the NRC think, that it is identified very early on and not after an application has been submitted and then needs to be addressed more formally in a way that takes a lot more time and energy to resolve. So there's, on that sense, there's both sides have to bring something to the table. The applicant needs to come and identify where they think the key policy issues are and be willing to engage with the NRC. And the NRC needs to be willing to provide constructive feedback that can help inform the applicant. And I think what both sides should be focusing on too is, how can we make this process more efficient overall? It goes without doubt that an applicant needs to submit a very high quality application. And in doing that, it's looking at what the regulations say, looking at the applicable guidance, figuring out, which can be difficult when you have guidance documents tailored for a very different technology, but figuring out how you need to apply it, looking at RAIs submitted in other proceedings to see where the NRC staff had questions and were focused, and trying to incorporate that into the application that you're drafting. But with that said, the NRC needs to be willing to provide constructive feedback that can help inform the applicant on what its contents should be. I have sat through any number of pre-application meetings where I felt like trying to figure out what the NRC was thinking was like reading tea leaves, where I'm trying to look at someone's face and gauge whether their eyebrows went up when we said something, or what if something was going to be a significant licensing impediment. And sometimes the NRC can and understandably so, when they're not looking at something that's written and put before them, they can be a little bit more reserved in providing their feedback, but providing more open and constructive feedback to help inform licensees and what they're doing, particularly when they're making design decisions, can be critical in ensuring that you maintain that alignment and you maintain that efficiency and that everybody, stays on the same page. Once an application is submitted, there's a number of areas that the report identifies, and that was based on the experience of not just myself, but any number of other people that have gone through this process and who provided their great feedback on the draft paper. But there's always going to be a tension between the scope and content of the technical portions of an application, particularly since a number of the people at the NRC are engineers and they want to know more and they want to see more, but making sure that those additional questions and the push for more scope and content is tied in with a need versus a curiosity, and making sure that requests for additional information are really honed in on things that are critical for knowing for the NRC to be able to make its safety and environmental decisions. And over the years, I have seen very tuned in RAIs that require, by the way, in order to do this, you need strong management. You need strong management who are willing to step in and say, do we need to know this? And so when I have seen strong managers, I have seen very, honed in RAIs that focused on where it needed to go. But I have worked on, particularly in the COL space, endless amounts of RAIs that didn't appear to have any relevance for a safety or environmental determination, any basis in the regulations, just seemed to be curiosity that the NRC was like, well, let me ask some more questions about this. And, you don't want to create that perception, and you certainly don't want to create that reality if it's not necessary in order to do a safety or an environmental review. And so just staying more honed in on the RAI responses, and then on the applicant side, being disciplined in responding to them. Sometimes you need more time because it's a complex question, but otherwise try to stay in the timeline that the NRC gives you for responding to those requests so that everybody can keep things moving on and you're not running into delays. The other areas that I had mentioned earlier is just really focusing in on early commission resolution of key issues. Again, in the LES licensing proceeding, having the commission set the duration of the licensing review meant that it wasn't just a milestone or goal somebody was trying to achieve, and that could be a little bit more loosey-goosey and missed, and it wouldn't be a big deal. It meant the staff was going to follow that licensing schedule, and that the licensing board was going to follow that licensing schedule, and it was adhered to, and it worked really well without in any way compromising a safety or environmental review, because it was a very comprehensive review, but it kept everybody on track and focused and made sure that efforts were really spent where they needed to be spent in order to meet that schedule. At the same time, the licensing board and the NRC staff readily flagged issues that needed to be resolved. It was a first of a kind licensing of a uranium enrichment facility, and it raised a number of novel policy issues. And the commission and the licensing board and the staff were both ready to flag issues and get them resolved. And the guidance that the commission provided throughout the licensing proceeding helped save an immense amount of time, and also helped keep the licensing board contested hearing on track. So you weren't litigating issues that ultimately would have been dispositioned by the commission for being outside the scope of a contested hearing. And so there's a lot of lessons learned. And I think maybe just to bring it back to, a theme that Alex tied into at the end, communication is key. Making sure that an applicant communicates clearly its expectations and its plan with the NRC, making sure the NRC clearly communicates that back, identifying and communicating issues for resolution early on in the process, and then keeping an open dialogue going so that people can make sure that they continue to remain on track. And with that, I will hand the microphone back to you, Steve.
Well, thanks, Amy. Thanks for going into that and reflecting on your experience with the various proceedings and in which sometimes I think NRC did a good job, and sometimes it could have done better with. I'm going to start off some questions, and participants or those tuning in are welcome to put forward some questions, and I will try to get it to all of them as we can. But just to give some context, maybe Alex or Amy, you could just talk about what the current status of advanced nuclear reactor technology is. We've mentioned a couple companies there. And in that context, also, how quickly do we see some of these technologies reaching potential commercial status?
Do you want me to cover that, Alex, or do you want to?
I can start on that. So one thing that I think is really important to recognize about the advanced reactor space over the last 2 years is that it's accelerated, and it's accelerating faster and faster. And what we're seeing is that a lot of work that companies have been putting into their designs and getting ready to go to market is really starting to pay off. And so when we look at that from a licensing and a commercialization perspective, what we've seen is that we have NuScale, which got its design, it's finishing up the final parts of its design certification right now. It's looking at doing a major project in Utah that would be complete by the end of the decade. We've got the 2 advanced reactor demonstration project winners. We got TerraPower, which is looking at developing a power plant to replace an old coal-fired power plant in Wyoming. We also have X Energy, which is looking at doing a plant in Washington. Both of those groups are going to be both of those companies are going to be doing licensing relatively shortly. And because of how those projects work, the online dates for those are 2028. And so they're going to have to get licensed and built within the next 7 years, and increasingly getting shorter and shorter time frame. So they're moving forward quickly. We also have other companies that are at different stages in the process. Oklo is currently going through its combined license application. I believe they're about 1.5 years in right now, and they're targeting some point in the mid-2020s to have their first microreactor online. The microreactors are in particular, it's worth kind of flagging because they're so small and the project timeline is so short. We actually see a lot of those applications relatively shortly, and we could see a lot of those reactors built by 2030. And then finally, we have Kairos, which just entered the application process for their prototype reactor. That's part of this phase plan to get something commercial by 2030. So we're really looking right now, if you look at where the market is, the developers are actually starting to the point of having very broad conversations with utilities for either first of a kind reactors, if it's some of the other developers that I didn't mention, or second of a kind or third of a kind reactors for some of the developers I have mentioned. So this is something that the market is really starting to arrive here. And I think this week is appropriate. NuScale just yesterday, it was announced that they're going to be going for they're going to go public with a SPAC and a $1.9 billion valuation. So this is something that this market is becoming real very quickly. And this licensing question is something that we're going to have to figure out to get right.
Yeah, and that was a great summary, Alex. The only thing I would just add is, those are the ones that have pending or imminent license applications. If you look at just the Advanced Reactor Demonstration Program, there were 10 recipients in 3 categories. The first were the demo categories, people who are immediately ready to license a demonstration facility, which is a full-scale commercial facility, and that was TerraPower and X Energy. And then after that, there were the companies that needed to do some more R&D, but that would deploy in the early 2030s. And then behind that, there were companies that were looking at deploying by the late 2030s. And of the companies that Alex just listed, Kairos was in the second tier, and X Energy and TerraPower were in the first, which leaves 7 other companies that were planning on deploying facilities in the early to late 2030 timeframe. And those are just ARDP recipients. There's a number of other private commercial facilities that are planning on submitting applications in the near term as well.
Good, thanks. And so I think you all have touched on this, but again, if you want to emphasize the points, what do you, in terms of, as the report says, that timely licensing reviews are essential. Why is that? What is so important about trying to meet, say, a 24-month goal and not worrying about whether that slips over to 36 months or whatever? What's so important about trying to stay on track in those goals?
Yeah, for sure. So for me, it's just, we want advanced reactors because we want to reduce emissions as much as possible, as fast as possible. And that means building as many reactors as fast as possible. And so when you just look at how we've seen things happen historically with technological learning in other sectors, by having a short project life cycle, you just increase the pace of innovation. The quicker the innovation happens, the more competitive these reactors will be, and the quicker we can get them to market at scale.
Yeah, and I would just add, Steve, from a climate change perspective, right, we have a very big task ahead of us. I just got back from a week in Glasgow at the COP summit, talking about decarbonization of the electricity sector, and I'm the head of the global energy practice at the firm. And so I am a nuclear specialist, but I work on all different types of energy, and certainly am familiar with all different types of energy by virtue of our practice on a global scale. And this is an immense problem. You know, the electricity sector makes up about 25% of greenhouse gases. Nuclear technology can be used to help decarbonize that, but it also can be used to help decarbonize the industrial sector, which makes up about 30% of greenhouse gas emissions. There may be other applications in the transportation and the agricultural sector that I haven't quite thought through yet, or we might not be there yet, but when technologies like Oklo start to take off, we have a lot more flexible applications that may come into play. And so decarbonization is an intense activity. The vast majority of power, not only in the United States, but around the world, is from fossil fuel. At the same time, we need to decarbonize the power generation that we already have. We also need to immensely increase the amount that we are producing, because the global energy demand is sharply increasing. And we need to provide power to the nearly 1 billion people in the world that don't have access to it, which is a global standard of living issue and a human rights issue. And so it is a big issue. And the US will not be able to decarbonize our power sector while at the same time making sure we maintain grid stability and energy independence without nuclear playing a key role in that. We also don't have any offerings overseas unless we start building facilities in the United States. It's a lot harder to then engage in nuclear trade. That is really important for nuclear nonproliferation, setting US safety and security standards, geopolitical influence, and climate change.
And one more thing that I would add kind of to your specific question of like 36 months for 24 months, it definitely matters at this very macro scale, but it also matters at a project level. And one issue that I think is really the nuclear industry struggles with how things have happened historically with conventional reactors is that there are a lot of schedule and cost overruns. And so when you're looking at how to deliver advanced reactors and make advanced nuclear energy cheap, the schedule is a huge part of that. And so to the degree that you can go to a customer and say that, hey, we don't think licensing is going to take 3.5 years plus with some uncertainty. When you say that we're pretty sure right now we're getting our licensing under 2 years, that greatly increases their confidence in the overall likelihood of the project going forward. And one other thing is for microreactors specifically, a microreactor, especially if you are doing some of the designs out there, there's mobile microreactors, they have different project lifetimes. And so instead of doing a reactor that's 40 to 80 years like a conventional reactor, some of these reactors are 20 years or shorter, or might have other sorts of things like that, that having a 2 to 3 year project life cycle is really critical to being able to meet that application for a remote community, for a mining operation, for things that we just have never actually had to deal with in the nuclear industry before. We want to be able to serve and decarbonize that load.
Okay, thanks, Alex. And I was just going to echo something what Amy said from my own experience as a commissioner and as chairman, particularly on the international scene. It's extraordinarily important to the extent that the U.S. wants to have the foot forward in terms of nuclear safety and nuclear security, for there to be a credible environment for nuclear technologies, particularly in the export area. And I know even since I've left the commission, that in a couple of engagements I've had with what I'll call new entrant or newcomer countries, what they're looking for is they have a responsibility under basically the Convention on Nuclear Safety and other international standards to be able to assess and appropriately regulate and oversee its technology. But they're looking for that help. Where has that technology been approved? They're looking for mature countries like the United States and some others, and Canada, UK, et cetera, and in terms of looking at how to deploy those technologies and learning from them to be able to do it. So I think that is extraordinarily important. Let me turn to we talked a lot about, been talking about the pre-application review, which I think is a very interesting thing, and I think both Amy and Alex touched on some lessons learned from earlier engagements. I think certainly from there are positive things from the NuScale engagement, but I know from, again, when I was commissioner speaking to NuScale, there are probably things we could learn from that. What should developers anticipate? These are advanced reactor developers anticipate when they're preparing for an application and trying to engage in this pre-application review.
Sorry, I don't want to talk over Alex. So I keep pausing.
No, please.
So, I think, Steve, the low-hanging fruit, right, is seeing what's already been done, right? The NRC is a fairly predictable agency. It likes to do things the way it's done it before. And so going and looking at REIs and similar licensing proceedings, the NRC is also good at pointing you towards maybe an application that seems like a little like it wouldn't be so squarely aligned with what you're looking at, but really is helpful for what you're trying to do. I think anticipating where you need more guidance and really honing in pre-application and going in, I think during pre-application, it's always important and is your official meeting to have kind of the scene setter, like this is who we are, this is the project we're planning on building, this is our technology. And then, saying, hey, we want to continue this engagement, focusing in on the key issues that we'll know will be of concern. And so, and then really taking a hard look at your technology, a hard and honest look at your technology and saying, what are we doing different that the NRC may have a harder time accepting, or what licensing approach are we proposing that is different than what the NRC has done before? And then how can we justify it? And then go in and have a discussion about it to see if you guys are on the same page, if the NRC is on board. And then if you're not, how can you proceed forward? Is it a matter of the applicant changing course, the NRC changing course, or trying to compromise?
Two specific things I would add in that we really got from feedback from talking with applicants and some other people that work through the NRC process on the NRC side is the idea of having a specific ask, and then also having clear expectations in terms of what you're trying to get out of the engagement itself. And so when we look at having a specific ask, when you're going into pre-application, there's a bunch of different ways that you can do engagement. And so sometimes you're going to be doing things where you're just trying to get some measure of feedback. Other times you're trying to get what's called finality. You have some sort of regulatory question that you want to actually have a safety review on, and would involve a topical report. And so there's this kind of balance between we're just trying to get information to help us internally structure our application to no, we're actually trying to retire regulatory risk with finality. And so being able to have an applicant think about that very specifically over time, figure out what your asks are, what you're trying to do. Are you trying to just get some information? Are you trying to actually help, one important thing, help the NRC know what they need to do staffing wise for your application when it comes in? Or are you actually trying to retire some of the regulatory risk that you think is most important? One thing that we did find that was interesting is that there's also a project management question on both the applicant and the NRC side. And one thing that had happened before is that when you don't have finality, if you have any sort of just natural staff changes, because there's a large amount of staff retiring right now, that can impact things if you have nonverbal agreements or things that are not at the level of finality. And so you have an expectation going into your application based on some conversations you had, and there's certain things there that you want to actually firmly establish that finality for. And also on the NRC side, make sure that some of those ideas or some of those things that have been talked about have intellectual lines of succession to make sure that those discussions are passed down in certain ways.
And maybe just to supplement this with just a couple concrete examples so that you could see the value in it. When I was working on the licensing of a medical isotope facility that was planning on building the 2 10-megawatt reactors, an issue came up between the lawyer and the reactor designer about the applicable electrical systems. We had sent them the NURIG guidance that applies for commercial non-power reactors, and they said this can't be right. It's not prescriptive enough. And so they were trying to rely on NURIG 0800, which is what is used for large-scale nuclear power plants, which is several hundred pages long versus 4 pages long. So the commercial non-power reactor guidance, and same with the research and test reactor guidance, is 4 pages for the electrical system versus hundreds of pages. And it was a significant design issue that needed to be resolved early on. And so we flagged that along with a whole host of other issues as well, as things that we needed to disposition in pre-application because it impacted the design of the facility. And, the NRC was able to readily agree with, and this is where it's important for the NRC to be able to provide this feedback. We're able to agree, yeah, no, you need to apply. You You can do whatever you want, but you can do the much more expensive, more complicated route if that's what you want to do. But we have a much more permissive route if you want to use the guidance for the research and test reactors, and that would be acceptable to us. And so that was a key issue. Another issue that's come up is, when do you need to put in place a QA program? And, that seems like it's not that really big a deal, but that has resolved that issue has caused contested hearings. And that came up in a contested hearing for one of the licensing of the combined operating licenses, the COLs. And so being able to just go in and disposition these issues so that, when do I need to set up this program? When do I need to have it in place? Or like, am I okay for now? Particularly when you're earlier on in the company phase. Those are really important things, and they can have significant outcomes later on, and then provide issue certainty earlier on when you're doing design work.
Yeah, that's interesting. And I'll tell you, from my youth, decades ago, QA was the big issue in terms of the existing fleet. I'm going to share a couple things. One, Amy Cubbage from the NRC, who's deeply engaged in the advanced reactor and new reactor license. She did want to point out that there is NEI guidance for regulatory engagement plans that can be used. Another question we have, which is anonymous, so I'm not going to put this in with Amy Cubbage, but one of the questioners is asking whether the writing team on the report were aware of actions NRC is doing to promote robust pre-application engagement and other activities to promote efficient and effective reviews, including the use of core teams and safety-focused reviews. That's the comment that was made. And Alex, you want to maybe respond to that?
Yeah, so one thing that it's useful to kind of emphasize at a high level about this report is that this report is capturing a lot of things that are happening, changing, in progress right now, and also trying to open the door for future conversations. And so the use of core teams, I think, has actually helped a lot. And that's something that we've heard as really good feedback from a lot of developers, is that now that that is being used more often, it definitely is making things better on the pre-application side. NRC did release a draft pre-application white paper that I think had raised a number of issues with it, because a lot of it required a lot of information to be able to get a 6-month reduction in your time frame. But to actually do that would take about 2 years. And so to remove 6 months from your application time frame, but add 2 years of pre-application that's pretty fixed, is not necessarily a tangible benefit. And so one of our recommendations there is that if you do something like that, probably try and target at least 12 months. But this is something that there's a number of things like this that are ongoing that we did talk about in the paper, that we actually think that one of the issues here is just even having basic information sharing across all the activities that are happening. NewScale only just really completed their design certification and did lessons learned in the last 1.5 years or so. And so this is a moving process with a very large regulatory entity and a large and growing industry. And so trying to figure out ways to actually identify these best practices and share them is really important. And one thing for that I'm really want to emphasize is that once we go beyond just these developers and you go to utilities that have not actually been dealing and focusing on this issue with their staff for the last 5 years, there's going to be a whole host of ways that we can try and make sure that they're doing best practices and that they're also aware of what the NRC is doing and how the NRC is changing.
Yeah, maybe I would just add, there were a lot of stakeholders that provided feedback into this report, including NEI. So it was a pretty broad and comprehensive review. And plus the NRC actually does a fantastic job at transparency in terms of putting things on their website. So I don't think that there was anything that came out that affected the licensing for advanced reactors that was not thoroughly reviewed by the people who were working on the paper.
One question for posed to you, Amy, and I know this has been an issue, as I say, when I was still on the commission, as we were looking forward to accepting these applications. But can you share your thoughts on the importance of how to handle the issue of license exemptions from parts of the existing regulations during the pre-application process? And as we know, you touched on this goes back to that the current set of regulations in terms of the substance, not so much the procedure, but the substance, focus on light water reactors. I hate to say it, the general design criteria were adopted in 1970 when I was still in high school. But in any event, maybe you can address how we deal with that exemption issue prior to perhaps getting to somewhere with a new Part 53.
So that is a very good question. Something like exemptions and making sure that the applicant and the NRC are on as much as the same page as possible during the pre-application stage means that when you're actually doing a licensing review, you're not reworking content and rewriting applications. Content is difficult and it can get messy, making sure that the reviewers have kind of a complete application up front. And licensing exemptions is a great area where there's going to be, for a number of advanced reactors, there's going to be a whole lot of exemptions that apply. And you just need to make sure that the exemption is correct, because if it's not, you then have to then go supplement your application to correct whatever it was that exemption would have covered, or otherwise try to resolve the issue, within the NRC to see if you can kind of bring them around to your side. And again, during a licensing review, when the clock is ticking and the application is already supposed to be essentially complete, exemptions can become an incredible pacing item and are a lot more stressful to try to disposition during a licensing review than during pre-application review. And every time you change an application, not only do you set the clock back, but you also open the window for interveners coming in and challenging new things as well. So trying to get the application as final as possible and not doing rework is in the best interest of all parties.
Okay. And along that lines, another question you just popped up, and it concerns the idea of greater finality in the pre-app discussions. And this question assumes that requires like a full SER level of finality. Would you agree with that? I'm not sure that's
only if you're doing a topical report or a technical report.
Yeah.
Right? We didn't, for the example that I gave with the electrical system, we didn't need to do a technical or topical report. We were on the same page, right? And I would consider that the answer that we needed. So, other than that, you don't need that SER level type formality, I think, again, unless it's for a paper that you submitted to the commission, to the NRC that requires an SER type review.
Okay. Another question got here is, how do you see from Alex and Amy, how do you see from this report or your experience, the readiness of industry to enter the licensing process and the availability of technical basis and associated data that they may need to do so?
Yeah, so that's something that I think, in part to my initial comments, that I thought I've seen really this industry, I think, accelerate in our last several years. There's been a lot of work to establish sufficient technical bases for some of the designs that are coming into the licensing process right now. That's going to be an ongoing process, especially when we start getting into some of the materials that we're looking at using for the first time, fuel qualifications, things like that. It's going to be an ongoing challenge, I think, just because the diversity of advanced reactor designs that we have all sorts of novel technological issues, and you are going to need to establish the technical bases for each of those. One thing I will say that I think is really interesting right now is that there are a growing amount of topical reports that are available right now because there's so many applicants going through the process that's actually going to just improve the overall efficiency of licensing for everyone. Because when you have one applicant come do a certain technical review or go through a regulatory process, get a specific exemption for the first time, that then establishes a framework for other people to then start building upon that and using that. And so that is something that, as we start getting to, say, the fifth or sixth or seventh application, I think you're going to see that technical stuff for certain things resolved. But other things I think are going to be challenging. So like doing a full probabilistic risk analysis for, say, a new novel reactor type, it's really challenging to get that data right now. It's really expensive. And you're going to have to do a lot more work for that than you would have had to do with a PRA for an existing light water reactor, because we have so much operational experience there.
Yeah. And again, just to underscore the importance of pre-application, right? Unless you want to sit there and read everything on the NRC docket, going in and doing that pre-application discussion with the NRC allows them to be able to point you to the topical reports or the technical reports or the other precedent that you may be able to rely on to help streamline your own application.
Great. I think I've got time for about one more question. And this touches on, I think, the very intriguing parts of the report and the comments I've heard from Alex and Amy with respect to ongoing engagement within the agency itself. as the process goes forward. And in some way, I mean, I hate to say this, but the image that came forward was almost like Jacob's ladder. And so the angels, and those are the NRC staff, going up and down, up and down the ladder. But it's not a bad simile, because from the standpoint is that you have the staff level folks who have to engage with it. You have at a management level who need to oversee the staff, make sure they're meeting their objectives, You have the commission that sets policy issues like that. Then you also have injected the potential for, if you have like a Part 50 construction permit or operating license, you're in an adjudicatory space, which you aren't in a Part 52 design certification. And you've got to negotiate all those types of things. Any thoughts about how best we can do that? And Amy, you did touch on some lessons maybe from LES.
Yeah, so in the LES proceeding, maybe I'll use two lessons, right? The LES proceeding, the STP 3 and 4 proceeding, and I'll try to be super quick. So in the LES proceeding, those issues resolutions, they went up to the commission, they went back down. I didn't see the staff skipping a beat. I didn't see the licensing board skipping a beat. While something went up to the commission and the commission was reviewing it and then dispositioning it, other things moved on. The great thing about these licensing proceedings is there's a lot of things to review. And just because you need guidance on one aspect, doesn't mean you can't continue to review in other areas. And the good news is that when you get it back, particularly when it comes from the commission, that's it. That's the law of the land. And definitively that's what it is. It's not a management decision that then may get overturned or may get challenged and then goes up to the commission. And then maybe just to shift it over to like where it can get really messy was like in the STP 3 and 4 proceeding, where the biggest issue was the FOCD issue. And, Toshiba had a 10% investment in the applicant that was 90% owned by a US company, NRG, but was providing a significant amount of the financial support for the remainder of the licensing. And an NRC staff person said, this violates FOCD. And then the management just said, okay, that's fine. OGC said, okay, that's fine. And then, they got to the point where they said, tell us why we shouldn't dismiss your application. And that probably at that point should have been gone up to the commission rather than have a letter go out saying, we know that you spent $1 billion in this project and we're at the end stage of a licensing review and, do we dismiss your application? But it didn't. And what happened was an intervener then submitted a challenge, and that ended up being a godsend for the applicant because the intervener had an FOCD challenge. It provided a clear path at the licensing board to disposition the issue, and then it was overturned by the commission. And so the commission said, no, there's not an FOCD issue, but it got there in a different way. It could have gotten really messy if they were going on at the same time, but until it was a contested proceeding, it should have gone up to the commission, I think, while it was with the NRC staff. And so it gets messy. And there are ways that it can work well and ways that it's not. And at any time, you're going to have to adjust for the specific facts that you're dealing with at the time.
One thing just really quickly on this that jumped out to me, and I think you can see it throughout each of our 4 major recommendations and also with our work broadly, is making sure that the NRC specifically has the institutional capacity to handle the growth in reactor applications and also to exchange lessons internally. And this is something that I'm personally concerned about, even beyond the NRC, just human resources in this sector, because a lot of the NRC staff are set to retire. NRC had a hiring freeze for years. The amount of their staff that's under 30 is really small compared to comparative agencies. And there's also not clear lines of succession within the NRC when you have expertise. And so we're going to have to rebuild that within the NRC and make sure they've got the capacity to handle really hopefully dozens of these applications. And at the same time, same thing for the applicants themselves for these advanced reactor license, these advanced reactors are going for licenses. They need to make sure that they have a growing staff that's going to need to have all these lessons learned. They're going to need to be able to do these applications efficiently. And so there's this capacity question that I think cuts across this report and even more broadly.
Yeah, thanks, Alex. And I would say that has been an issue and continues because you do have the generational shift, and you have fewer people. I have to say it would be people like me who were involved in the late 70s, early 80s in terms of licensing, and even though that was the light water technology, there are things you learn. But I know I will give credit to the staff because there is a a certain amount of sort of knowledge management and all that has been important to the agency over the years. Well, that's about time to wrap up now. I want to thank both Amy Roma and Alex Gilbert for the discussion today on, I think, a very interesting report. I'm going to highlight the online resources. I think the report is available through Nuclear Innovation Alliance's website, which is www.nuclearinnovationalliance, all one word, .org. And also you can follow their Twitter account at the NIA.org, THENIA.org on Twitter. So again, I thank all of you for tuning in, and I thank you for the rich discussion. And I think actually NIA has put the two links up in the chat, so you can see that. So again, thank you, and everyone have a great rest of your day. Take care.
Thank you.
Thank you both. Bye.